All right, so we're back with a video on using summation formulas. I'm Mr. Angstadt-Williams. Before we get started, we would like to thank our corporate sponsors. So Sticky Feet Reptiles and the Crafty Badger, we appreciate your continued support. During this video, I'm going to be referencing some formulas for summation. So just to give you guys a quick heads up, these are the formulas when I reference that I'll be using. So let's look at the original problem. If I look at the original problem here, let me stop sharing. So the original problem I have is the sum from k equals 1 to n of 6k times k minus 1 all over n to the third. So in order to use my formulas, I need to break this up and simplify it quite a bit before I get started. First thing I do is distribute that 6k, and I get 6k squared minus 6k. Then I recognize that n to the third is a constant, so I can pull that n to the third out because it's in the denominator. I pull it out as 1 over n to the third. Then I also have a property that says I can separate these out into the sums of the two individual pieces, 6k squared and 6k. Then I look at my 6 and I say, well, 6 is a constant I can pull out, 6 is a constant I can pull out. So I have 1 over n to the third times the 6 times the sum of k squared minus 6 times the sum of k. So from this point, I can start using my formulas because I have a formula for a squared term. In the formula sheet, it said I squared. I have k squared. And I also have a formula for k, or in the formula sheet, I. So now when I break this up, I need to break it up into individual pieces. So what I'm going to do is I'm going to keep that 1 over n to the third on the outside. So 1 over n to the third. I'm going to keep that 6. And then I'm going to change k squared to my formula. My formula is n times n plus 1 times 2n plus 1 all over 6. So that's that first piece. That's 6 times the sum from k equals 1 to n of k squared. That's what this becomes. I'm going to subtract off 6 times my k formula, which will be n times n plus 1 over 2. Right? So I get something that looks like this, and I'll finish it off with my bracket for that 1 over n to the third. Now, from here, it's all just algebra, right? How can I make this simplify down and look a little bit nicer? So let's first distribute this through, right? So I have, and let's cross the 6's out. We can say that if I have 6 on top, 6 on the bottom, those are gone. So this is 1 over n to the third. If I distribute that n, I get n squared plus n times 2n plus 1. And then 6 over 2, I can say, well, that's just 3. So then in 3n, if I distribute that through, will be minus 3n squared, and then minus 3n times 1 is minus 3n. So it's starting to look a little nicer. I'm going to FOIL these together. I'm going to keep this 1 over n to the third out there. If I FOIL them together, n squared times 2n, n squared times 1, and then n times 2n squared gives us 2 and 1, which is 3n squared, and then plus n, minus 3n squared minus 3n. So I just FOILed this out, combine my like terms, and I get this. Right? I can look to combine more terms. I have this n to the third. 3n squared minus 3n squared is gone. And then n minus 3n is negative 2n. Well, what do these have in common? They have an n in common, so I can take an n out. If I take an n out, I can cancel this out. So I can cancel one of these out, and that out. So I have 1 over n squared times 2n squared minus 2. So to make that look a little nicer, we'll say, just combine it into 2n squared minus 2 over n squared. And you could factor a 2 out of the top if you'd like, but it really makes no difference from there. So in order to solve these problems, right? We have to first simplify, and we have to simplify to a point that we can use the formulas, right? We have to break it down, take constants out, separate them out into individual pieces. Once I apply the formulas, then it's just algebra, right? Trying to simplify everything down, combine like terms, get everything together to make as nice of an answer as possible. And that's what we have here. So that is our using summation formulas. We may do another video on that soon. Make sure you like, subscribe, and comment if you want to see something else in our videos.